Well, hello again, everyone. Welcome to our discussion of section 1.10, where we will be talking about the slope of a straight line, finding the equation for a parallel line. That is, if you have a line, a straight line, how do you find the equation of another line that is parallel to that? And also finding the equation for a perpendicular line. So if you have already the equation of a line, how do you find the equation of another line that is perpendicular to the current one? So just a reminder before we start covering these three main topics, that the way to study for this course is first, before you watch the video or come to class, please skim through the textbook section that is going to be covered. Spend no more than an hour. If it's a very long section, usually you should spend about half an hour to 45 minutes reading through the section, and then attend the class and take lecture notes that are useful to you. That's item number 2. And then review your lecture notes while you solve all the problems that you saw me work on in class or in the video on your own before you see the solutions. And complete all the homework assignments by the due date, and then of course review as we go through the semester. Okay, so the slope of a straight line, it's what you see here, that's a straight line. And the slope of a straight line, once you figure out what that number is, it's always the same. It does not change. That's the very definition of a straight line. The slope of it, it doesn't change. But of course, that's not always the case. Slope, most often in the real world, slope represents rate of change of something, and that changes often, and according to time, according to physical condition, environmental conditions, and all of that, environment. And for slope that changes, that's what we mainly talk about in calculus. Calculus is the focus of calculus, is talking about slope that, or rate of change of some quantity that goes through constant changes. It's constantly changing. It's never the same. But in this class, we will talk about slope that is constant. So suppose you have 2 points, and these 2 points at x1 comma y1 and x2 comma y2. Suppose you have a straight line that is connecting those 2 points. Then the slope of the line that connects them, it can be calculated with this formula that depends on the coordinates of those points. So you can say y1, or the y component of one of these points, minus y2, which is the y component of the other point, divided by x1, which is the x component of this point, minus x2. So can you say y2 minus y1 instead of y1 minus y2? Absolutely, you can. But you have to keep the order of subtraction in this formula. You have to keep the order of subtraction the same for the numerator and the denominator. So if you say y1 minus y2 in the numerator, then you'll have to say x1 minus x2. If you say y2 minus y1, then you'll have to divide that by x2 minus x1. So the order of subtraction has to be the same. If you say y1 minus y2, then you have to say x1 minus x2. Okay, that's the important thing. Order of subtraction stays the same. Okay, so then the formula that you see here, that is commonly known as the point slope form of a straight line. Right there, we've defined that. The point slope meaning x1, y1 is the point, right? See, one of those points is x1 comma y1. It could be that point. It doesn't matter. Any point on the line will do. So one way to represent the equation of a straight line is using this formula such that x1, y1 are the components of any point on the line, and m is the slope. M is usually, the lowercase m is the letter used most commonly in textbooks to represent slope. But it could be anything. It could be any letter, but that's what it is mostly used for the slope. And this equation in general is very useful when you're finding the equation of another line that is parallel or perpendicular to another line. So you can use other equations, but this one, given the experience I've had teaching this subject over the past 19 years, that's always my students prefer to use this formula. So that's what I picked for this worksheet. But you can also use this formula. You can also use the slope-intercept formula to find the equation of another line. So slope-intercept equation. So that is the slope, and b is the intercept. Okay? So that is the intercept, and m is the slope. So you can use either this or that for finding the equation of another line that is parallel or perpendicular to another line, but people prefer this one more. This formula in general, used for that purpose, is more efficient than this, because once you know the coordinates of one of the points and the slope, you can just find the equation. Whereas that one, then you have to find the slope, then you can pick one of the points and then find the intercept, and then you have to put together the slope and the intercept to write the equation. But this will do that all for you in one go. Okay? In one go, it'll give you the whole equation once you know the slope and the coordinates of one point on it. So this one gives you the intercept as you simplify it. It'll give you that anyway. Okay. So required conditions, this is a required condition for two lines to be parallel. So if you have a line that is like that, let's say line A, right? There are how many lines do you think there are that are parallel to this one? How many lines? Infinitely many, right? There are infinitely many lines that can be drawn parallel to this one. So every time you're asked to find the equation of a line that is parallel to some line, you always get the information about what point the other line, the parallel line, must be going through. Because if they don't give you that point, then you have infinitely many lines to find. So which one? So as soon as they say, find a parallel line that goes through this point, then they'll narrow it down to just one line. Because out of those infinitely many possible parallel lines to another line, there is only one line that could go through that point. That's why whenever you are asked to find the equation of a parallel line, you're always given a point as well. So if this was a question, you would say, you would see something like this. Find the equation of a line that is parallel to A and that passes through the point 2, 0. That point. That's 2, 0. Right? Knowing that information about the point that it goes through, that the line passes through, tells you that you're looking for that line. Not the one here, not the one here, not the one over there, that one. Okay? So, required condition for two lines to be parallel is that their slopes have to be equal. So, the slopes of two lines must be equal in order for them to be parallel. That's the condition for two lines to be parallel. So if you have this line and that line, then the slopes M1 being the slope of line 1 and M2 being the slope of line 2 must be equal for parallel lines. Okay, that's the condition for two lines to be parallel. So let's see what is the condition for two lines to be perpendicular. Okay, so two lines are perpendicular when they intersect, they form a 90-degree angle, like that. So that is 90 degrees for the angle between this line and that line for perpendicular lines. So what's the condition that, given that you have one line, or either this or that, what's the condition for finding another line that is perpendicular to it? Okay, once again, there are infinitely many perpendicular lines possible to either one of these two lines. So which one are we looking for? They have to give us a point that the perpendicular line passes through. In that case, we can find that specific line. So the condition for two lines to be perpendicular is that the product of their slope must be equal to -1. Okay, once again, for two lines to be perpendicular, the product of their slopes, m1 times m2, have to be equal to -1. Now, this is the way I prefer to remember it, but most of my students would prefer to remember this equation like that. Because if you solve this equation for m2 or m1, you're going to get this result. m2, or the slope of line 2, is equal to -1 over the slope of line 1. Or many people like to call this or phrase this as a slope. For perpendicular lines, the slope of one line is the negative reciprocal of the other slope. Okay, that's also a valid way of remembering it. But I prefer to remember it this way because it involves no fraction. But I know most of my students prefer to remember it that way. It's maybe because the way the topic was covered in high school. I don't know. But whichever way, these two equations are the same condition, written differently. It's the same condition, okay, for two lines to be perpendicular. So let's begin going through some examples. This one says the slope of a horizontal line is, there's a blank here, can you show y? Well, let's go the other way. Let's first show y and then give the slope. If we draw a tiny graph here, right? Suppose we have the xy plane here, and a horizontal line is what we're talking about, right? So let's draw a horizontal line like that, right? Then let's pick a couple of points on this horizontal line. Let's pick one point here and another point here, right, on the horizontal line. Now let's write down a general coordinate for each point. So let's call this point 1, point 2, right? So the coordinates of this in general would be x1, comma, y1, and the coordinates of point 2 would be x2, comma, y2, right? So now, if we want to calculate the slope of this horizontal line, we can apply this formula, can't we? This formula, y1 minus y2 divided by x1 minus x2, or y2 minus y1 divided by x2 minus x1. We can apply this formula. So let's do it. Let's see what happens. So the slope of this horizontal line would have to be y1 minus y2 over x1 minus x2, right? Just using those coordinates. Now, take a look at these coordinates. x1 and x2, would they have to be different values or the same value? x1 and x2. x1 and x2 would have to be different values, right? The x1 would be some negative number here, and x2 would have to be some positive number here. But x1 and x2 would be some different, two different numbers. right? So let's write them as x1, x2, two different numbers. How about y1 and y2? Would they be the same number or different numbers? y1 and y2 are going through exactly the same y value. So y1 and y2 would have to be the same. So for a horizontal line, y1 and y2 are the same. Let me write that down here. For a horizontal line, y1 equals y2. So if y1 equals y2, those are the y components of these 2 points, then what would this difference be? If y1 equals y2, what would this difference be equal to? It would be equal to 0. There. But 0 divided by any number, because x1 and x2 can be any number, so their difference can be any number, 0 divided by any number is equal to 0. Because 0 represents nothing. So how can we divide nothing by something? There's nothing there. So dividing nothing, we end up with nothing. So this means that the slope of a horizontal line is always equal to 0, right? Is always equal to 0. And can you show why? And we've already shown why, just by using this graph and 2 hypothetical points. Okay, I hope this is clear. So the slope of a horizontal line is always 0. It doesn't matter where in the plane it is. The slope of a horizontal line is always 0. So the slope of a vertical line is question mark or blank. Can you show why? So let's draw another graph for this. Suppose we have this. We're looking for the slope of a vertical line, right? So suppose we have this vertical line. Vertical to the x-axis, that is. Right? Something like that. And this is 90 degrees. So we have this vertical line. Now, just like before, suppose we pick 2 points. This one and this one. Let's call this P1 and that one P2. Right? Let's write down hypothetical and generalized coordinates for each point. So let's say P1. Let me move this up so you can see it better, like that. So suppose P1 or point 1 has coordinates x1, comma y1, right? And P2 or the second point has coordinates x2, comma y2. So using the slope formula, let's write down, which is that one, right? We used it here. Let's use the same slope formula and these coordinates to calculate the slope for this vertical line. So y1 minus y2 divided by x1 minus x2. Okay, so take a look at the coordinates of these 2 points. Now, the difference y1 and y2, would those be different numbers or the same number? What do you think? They have to be different numbers, right? y1 would be some number here along the y-axis. y2 would be some number here along the y-axis. On the positive side, this one on the negative side. Okay? So y1, y2 will have to be some number. Let's just write them down. We don't know what they are, but they have to be. What's important is that they have to be different numbers. They're not the same number. How about x1 and x2? x1 and x2 have to be the same number because this whole line is going through the same x value, right? This axis, x-axis, represents different x values. But this vertical line is going through the same x value. It doesn't zigzag. It just drops vertically, going through the same x value. So that means x1 and x2 must be the same value. So for a vertical line, x1 equals x2. Okay, the same value. If x1 and x2 are the same, what would this difference be? It would have to be 0. If x1 and x2 are the same for a vertical line, then the difference have to be 0, right? So because for a vertical line, the denominator of this formula is always 0, so we say that the slope of a vertical line is always undefined. Okay? That's for a vertical line. Okay, like that. I hope this helps you. I'm sure you've seen this before, but I hope if you didn't remember it now, this would be a refresher on that. Okay. Suppose now, let's go through these series of examples. This one says, find the slope of the straight line that connects these 2 points. Okay, so let's do that. So we know that the slope formula is equal to, we've been using y1 minus y2 over x1 minus x2, so let's use y2 minus y1 over x2 minus x1. And let's, for the sake of convenience and accuracy, let's label these points. So 0, 0 is x1, y1, and 6, 2 is x2, y2. Okay, so then let's plug in. Then y2 would be 2 minus y1, which is 0, divided by x2, which is 6, minus x1, which is 0. So we have 2 over 6, which simplifies to 1 over 3. Okay, so that's the slope of that. So again, the order of subtraction, you should keep it the same. If y2 minus y1 in the numerator, then x2 minus x1 in the denominator. Okay, so moving to the next example, find the slope of a straight line that connects the 2 points, these 2 points. Right? I hope you're pausing the video, answering these questions, and then coming back to the video. I hope you're doing that. So m, this time let's do y1 minus y2 over x1 minus x2. So again, let's label these x1, y1 for this one, and let's take this one as x2, y2. Okay, so let's plug in. y1 is minus 7. Minus y2 is 11. x1 is 4. Minus x2, which is minus 2. Right? Minus 2. So let's simplify. Minus 7 minus 11, that's minus 18. Divided by 4 minus 2 is positive 2. 4 plus 2 is 6. Minus 18 divided by 6, it is equal to minus 3. Okay? So what can we tell about, given these slopes, what can we tell about the lines they're associated with, even without graphing them? Is there anything we can say about the lines that have these slopes? Well, absolutely. We can say that this line, because it has a positive slope, so this line is an uphill going slope, or i.e. increasing slope. Increasing slope from left to right. Okay, it's going uphill from left to right. How about this one? Well, that one, it's a downhill going slope. So this is a decreasing, because it's negative, decreasing slope from left to right. By the way, in the graph of every equation, we read the slopes going from left to right. Okay? All right. So this one says find the equation of a line that has this slope. So this is m, or this piece. That means m equals -1 in the equations we've been talking about. M equals -1 that passes through this point. Okay? So we're going to use the slope point slope form. Using point slope form, of the equation of a straight line, right? We had that here on one of these pages. That's the one I'm talking about, this one. Using this point slope form of a straight line, using that, let's write it down. Y minus y1 equals m times x minus x1. So using that, now let's plug in with these coordinates and this slope we have. So this one is x1 comma y1. In this formula, that's what it would be. So y is y minus y1, that's 8, equals m, which is the slope, which is -1, times x, which is x, minus x1. x1 is -3. So minus 3. Okay? So let's simplify. Y minus 8 equals minus 1 times x plus 3. And then we have y minus 8. Let me move this up a little bit. Y minus 8 equals, let's distribute the -1 into this parentheses. What do we get? We get minus x minus 3. Y equals, let's simplify, minus x minus 3. Move this -8 to the other side of the equality symbol. It'll change algebraic sign to the opposite. And then finally, y equals minus x plus 5. Okay, so that is the equation of a line that has slope equal -1 and passes through that point. Okay. Find the equation of a line that passes through this point and is parallel to the line this. Well, what was the equation for parallel lines? Let's revisit that page. The condition for two lines to be parallel is that their slopes have to be equal. M1 and M2 have to be equal. But notice that before we know what the slopes are, the lines have to be written in this form, in the form of slope-intercept, in this form. If the lines are written in this form, in this case they are, then we know what the slopes are. Okay? But they have to be in this form. Y equals mx plus b. So, Is this line written in that form, y equals mx plus b? No. So first, let's write this in y equals mx plus b form. Because right now, we don't know what the slope is. We need to first write this in slope intercept form. So write this in y equal mx plus b form to know what slope it has. Okay, so let's do that. We're going to keep y on this side. We're going to move the 4x and negative 15 to the other side. So 4x move to the other side of the equality symbol becomes minus 4x, right? It changes the algebraic sign to opposite. Negative 15 move to the other side becomes positive 15, and we're done. So it took us a few seconds. We now have this slope-intercept equation, which is that form. So now we know what the slope is, right? So let's call this m1. Let's call this m1, or the slope of the first line, m1. Right? So m1 equals negative 4. So for two lines to be parallel, which is what we're looking for here, the slopes have to be equal. So we must have m1 equals m2 equals minus 4. Okay, so we have not found the parallel line yet, but we know its slope must be equal to negative 4. Otherwise, it's not going to be parallel to this line. Okay, so now we know the slope of the parallel line, and we know which point it passes through. So let's find the line. So now using this formula or equation, we can plug in, right? Let me come up here. Let's plug into this formula with this slope and this point, 4 comma negative 12. So y is y minus y1. y1 is negative 12 equals m, which is negative 4, times x, which is x, minus x1, which is 4. So let's simplify and figure out what this equation is. So minus 12 is positive 12. Minus 4x distributed into this parentheses is minus 4x plus 16. Y equals minus 4x plus 16. Move the 12 to the other side, it becomes minus 12. Y equals minus 4x, 16 minus 12 is positive 4. Like that. Okay? So that's how we find the equation of a parallel line. So this time, we want to find the equation of a line that passes through this point. Let's call this x1 comma y1. And it is perpendicular this time to this line. Right? So what was the condition for two lines to be perpendicular? Do we remember that? Let's look back at this page that has that information. For two lines to be perpendicular, the slope, the product of their slopes should be equal to -1, or solve for m2 in this equation, you get -1 over m1. Okay? So the condition here is m1 times m2 must be equal to -1. So, do we know the slope of this line yet? No. So let's write this in y equals mx plus b 4. Right? Let's do that. So we have 5y equals, let's move the 2x to the other side, it becomes -2x. Let's move the positive 2 to the other side, it becomes -2. Right? So we're not there yet, right? We need to write that equation in this form. We're not there yet because we have a 5 here. So let's divide both sides by 5. What do we get? We get y minus 2 over 5x minus 2 over 5. If you divide both sides by 5, that's what you get. Is this equation in this form? Absolutely, it is. So now, what is the slope of this line? Okay, so let's call this is the current line. Let's call it a slope of line 1 is equal to -2 over 5. Okay, so now we know the slope of the first line, or m1. Let's find the slope of this perpendicular line, or m2. So I'm going to use this formula as my equation to solve for m2. So I'm writing this down because some of you might be wondering how we can solve for m2, but you don't even need to solve for that. -2/5 times what number, you'll get -1. Well, times 5 over 2. So you don't have to go through this. If you see right away that the slope of the perpendicular line should be positive 5 over 2, you don't have to go through this. But for anyone who wants to know how we solve for the slope of the perpendicular line, I'm going through it. So using m1 times m2 equals -1, we have m1 is -2 over 5. m2 is what we're looking for, should be equal to -1. So multiply both sides by 5 to clear the fraction. Right? So 5 times minus 2m, or -2/5 m2 equals 5 times -1. This and this cancel each other out. We get -2 m2 equals -5, and then m2 is -5 over -2, which means m2 is equal to positive 5 over 2. Okay, so that's the slope of the perpendicular line, the slope of the line we're looking for. Okay, so now let's use using this formula, the point slope form. Using that and the fact that the perpendicular line is passing through this point, -1 comma -2, and the fact that slope m2, the slope of this line, is positive 5 over 2, that's what we just found. we can plug in and figure out the equation of the perpendicular line. So let's do that. Y is y, minus y1 is minus 2, so minus 2 equals m, which is m2 in this case, 5 over 2, multiplied by x is x, minus is minus, x1 is minus 1. Like that. Okay, so let's simplify. Y minus minus 2 is y plus 2 equals 5 halves times x minus minus 1 is x plus 1. So y plus 2, let's distribute the right hand side. 5 halves x plus 5 halves times 1 is 5 halves. Okay, so let's move this 2 to the other side and combine it with the 5 halves. When we move this positive 2 across the equality symbol, it becomes minus 2. Then common denominator would be 2, right? Because the denominator of this minus 2 is 1. So the common denominator between these two is 2, right? So then let me put that here. 5 halves minus 2 over 1. Let's multiply 2 over 1 with 2 over 2 because we need the common denominator. So what do we end up with? We end up with the common denominator 2, and then 5 minus 4, which is 1 half, positive 1 half, right? So we end up with, so this is, we can put that in this equation. So we have 5 halves x plus 1 half. Like that. Okay. I hope this is making sense. So here's another question, number 9. Again, we're looking for a perpendicular line that passes through this point. And here's the line that the line we're looking for must be perpendicular to. So please pause the video, write down your own solution, and then unpause the video and look at my solution. Okay, so here, let's write this. I'm assuming you have your own solution already, which is great. So write this in y equals mx plus b form, right? So let's do that. We have minus 8y equals minus 4x plus 1. Divide both sides by negative 8. We end up with minus 4 divided by minus 8 is positive 1 half. X. 1 divided by negative 8 is minus 1 over 8. Okay, so that's that equation written in this form. Now we know exactly what this slope is, right? The slope is 1 half. So let's call it M1. M1 is 1 half. So for perpendicular lines, we have a condition we have to meet, right? For perpendicular lines, we must have the product of two slopes. The slopes of two equations that are perpendicular must be equal to negative 1. So we know what M1 is. Let's plug in. We're looking for M2 such that M2 times 1 half is equal to negative 1. Some of you might have to solve this step by step. Some of you know right away M2 should be negative 2, which is fine. So let's solve it. So multiply both sides by 2 to clear the fraction. Like that. So 2 times 1/2, they cancel each other out. We get m2. 2 times -1 is -2. So this is the slope of the perpendicular line, the line that we're looking for. Okay? So now, using this equation, y minus y1 equals m times x minus x1, we already know what x1 comma y1 is, right? That's the point that the perpendicular line has to pass through. Okay, so that is x1 comma y1. And this is the slope. And m here is m2, -2. So let's plug in. We have y, which is y, minus y1, which is -2/3, equals m, which is -2, times x minus x1, which is 1/2. So let's simplify. We have minus 2/3, it's positive 2/3, equals, let's distribute the -2 inside this parentheses. So minus 2x plus -2 times -1/2 is positive 1. Right? -2 times -1/2 is positive 1. So y equals minus 2x plus 1. Move the 2/3 to the other side. It was positive on this side. When you move it across the equality symbol, it becomes negative. Minus 2/3. So this piece, take the common denominator. You have 1 over 1 minus 2 over 3. Right? What's the common denominator? 3. So this is already okay, but this isn't 3. So we got to multiply it by 3, and we got to multiply the numerator by 3. We have to do this to give this fraction, or 1 over 1, which is 1, the common denominator it needs to get subtracted from this one. So the common denominator is 3 now. 3 times 1, 3. Minus, this fraction did not have to be multiplied by anything, so minus 2. What do we end up with? 1/3. So then, let's put that here. The final equation of the perpendicular line is y equals minus 2x. We just added or subtracted 1 minus 2/3. We got 1/3. We got that. Plus 1/3. That. So this equation is perpendicular to this equation, and it passes through that point. Okay? Like that. Okay, with that, we have wrapped up section 1.10, and as usual, I thank you for persisting through this video, and for now, have a nice day, and I look forward to seeing you again next time.